Hey, welcome back. In this video, we'll explore the instantaneous rate of change using limits. In the first example, we will solve a word problem, and in the second example, we'll see how we can use the instantaneous rate of change to find the slope of a tangent line to a function. And at the end, I will give you an example to try on your own, and you can leave your answers in the comments. Now, with no further ado, let's jump in and solve some problems. Here's the formula that we want to use to calculate the instantaneous rate of change. The limit of f of x plus h minus f of x over h as h approaches 0. Let's look at the first example. The height of a ball is modeled by this quadratic formula, negative 5t squared plus 20t plus 2, where t is time in seconds. And we want to find the instantaneous rate of change at time equals 2 seconds. So if I want to use the same formula shown here, first thing I need to find f of x plus h, where in this case x is t and it's 2 seconds. So let's write that down. F of t plus h equals f of 2 plus h. And what I need to do here is to just replace t in this formula with 2 plus h. That gives me negative 5 times 2 plus h squared plus 20 times 2 plus h plus 2. Let's simplify this a little bit by expanding this linear binomial. That's what I'm going to get. Negative 5 times 4 plus 4h plus h squared instead of the first term. Now let's expand it a little bit more by multiplying out negative 5. That gives me negative 20 minus 20h minus 5h squared. And 40 plus 2 is a 42, and we also have a 20h. Now let's add the like terms and rearrange this equation, this expression, in a way that we have the term with the highest degree first to the lowest degree. So that gives me negative 5h squared plus 22. And as you can see, negative 20h will cancel with positive 20h. And now we have a binomial. The first term is a quadratic and the second term is just a constant term. Now that we have f of x plus h, the next term to find is f of x, where x is 2. So we need to calculate f of 2. And that's easy to calculate. It's just replace x with 2, and that gives you negative 5 times 2 squared plus 20 times 2 plus 2, which is equal to 22. Now we have these two terms. We just need to subtract, divide by h, and then find the limit. We want to find this limit, so let's replace each of them with what we found. Negative 5h squared plus 22 minus 22 over h. And that's good news because we can cancel 22s. Now this is simplified to negative 5h squared over h. You can cancel 1h in the numerator with the 1 in the denominator. That's simplified to limit of negative 5h as h approaches 0. So negative 5 times a very tiny number is just equal to 0. But what does it mean when the instantaneous rate of change is equal to 0? How do we interpret this? Okay, I think it's a good idea to look at the graph of this function. The graph of a parabola with a negative leading coefficient is this shape, this parabola, which opens downward, and the vertex of this graph is at 2 and 22. The vertex is the highest point, and in this case, we found the instantaneous rate of change at vertex, where the tangent line to the graph has a slope equal to 0 because it's basically a horizontal line and the slope of a horizontal line is 0. So instantaneous rate of change equal to 0, it means the slope of the tangent line equal to 0. Now that we talked about the slope of the tangent line, let's solve an example where we are explicitly asked to find the slope of the tangent line. Look at example 2 here. In this case, the function is a rational function, 5 over 2 minus x. And we're asked to find the slope of the tangent line at point 1 and 5. Again, we want to use the limit formula. Using this definition, the slope of the tangent line at point A in f of a is equal to the limit of f of a plus h minus f of a over h as h approaches 0. Please note that this is exactly the same formula that we used previously, but now instead of x, I use a. We basically replace x with a. So now I need to find f of a plus h and f of a, find their difference and divide by h, and then find the limit. And in this case, a is 1. So f of a plus h is f of 1 plus h. That's going to be 5 over 2 minus 1 plus h. So I just replaced x with 1 plus h. This is equal to 5 over 1 minus h, because 2 minus 1 is a 1, and then the negative sign times h makes a negative h in the denominator. Next, let's find f of a when a is 1. That's going to be 5 over 2 minus 1, that's equal to 5. Now we have f of a plus h and f of a. Let's subtract them and put it into this formula. So the limit of f of 1 plus h minus f of 1 over h is going to be the limit of 5 over 1 minus h minus 5 over h. To simplify this, I'm going to work on the top, where I need to find the common denominator. That's a 1 minus h. So we will have 5 minus 5 times 1 minus h over 1 minus h divided by h. And we can see that 5 and negative 5, they cancel out. Negative 5 times negative h makes a 5h. So we will have 5h over 1 minus h divided by h. Now this is the numerator and this is the denominator. Both of them have h. So you can cancel h and you will get the limit of 5 over 1 minus h as h approaches 0. This is the simplest form, and now I can replace h with 0. And that gives me the final answer of 5. Now, what is the meaning of having instantaneous rate of change equal to 5? So this is basically the slope of the tangent line at point of 1 and 5. And if I look at the graph of the function, 5 over 2 minus x, you can see the graph is shown with the light blue, and it has two asymptotes, the vertical asymptote at x equals 2, that's at 0 of the denominator, and the horizontal asymptote of y equals 0. If you want to learn more about the vertical and horizontal asymptotes, there is a video in the advanced function library. I will post the link to that video in the description. Be sure to check that out. So on the graph of this rational function, when I look at the point of 1 and 5, that's up here, and the tangent line is shown with this orange dashed line. The slope of this line is going to be 5, and that's what we found by calculating the instantaneous rate of change using the limits. All right, it's your turn. We have a quadratic formula, x squared minus 4x plus 6, and we want to find the slope of the tangent line at the point of 1 and 3. And we want to use the limit formula. Follow the same steps that we did in the first and second example and find the slope. Some extra work, you can graph the function and look at the point of 1 and 3 on the function and see how you can interpret the instantaneous rate of change by looking at the graph. And don't forget to leave your answers in the comments. That's it for today's video on instantaneous rate of change using limits. I hope you enjoyed it, and I hope this helps you to solve more math problems. And don't forget to solve the practice problem and leave your answers in the comments. And if you enjoyed this video, please give it a thumbs up, subscribe for more math contents, and share it with your friends. Until the next video, keep solving those math problems.